All right, last topic for this unit is looking at infinite limits. So we've been kind of fixated on the limit of a function approaching a particular value. So, like, the limit is x approaches 5 or x approaches 3. But what happens when we go to the extremes? What happens when a function has, or what happens when we want to see what happens or what's happening at a function when x is approaching positive infinity or negative infinity? So, here's an example of just graphically of kind of why we would want to look at this. So here's a cool little graph that has an asymptote, a horizontal one at y equals 4. Um, so what happens when x goes to positive infinity? Well, this is going to continue forever, right? And this asymptote is going to be here forever, blocking this function from ever hitting 4. But the limit as x approaches infinity of this function is still 4, right? That's right here. And then negative infinity, same deal. There's the asymptote on this side, and this function is approaching the asymptote. And again, this goes on forever. The function is going to move and approach y equals 4 forever. Okay? So graphically, it's kind of easy to see when if you go on Desmos, so you type in an equation into a graphing calculator, it shows you it, and you can see what's happening as you move on forever. Now, what happens when we want to actually, like, kind of look at a function like 1 over x? So here we um, probably remember what 1 over x looks like. So this is a ugly quick drawing that I made here. So as x approaches infinity, what's happening? Well, where is infinity? That's going this way, right? So as my function, right, as x approaches infinity, this is getting really, 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 really small. So it's approaching 0. Okay. Now this is going to be important when we have to evaluate infinite limits. Okay. So for this one also, like, what's the limit as x approaches negative infinity of 1 over x? Well, what is that? Well, it's the same thing. This one is approaching 0 from the other side. It's still 0. So we're going to use that to help us evaluate limits that are going to infinity without a graph. All right, I know, sounds exciting. So let's look at this one. Okay, so I have the limit as x approaches infinity of x squared minus x over 2x squared plus 1. So here what we're going to do is we're going to use a little trick to use the limit that we just did in example A. So what I'm going to do is I'm going to common factor from the top, like I'm going to take out an x squared. And then I'm left with 1 plus 1 over x. All right. And then from the denominator, I'm going to take out an x squared. And then I'm going to be left with 2 plus 1 over x squared. All right. Now you may be wondering, why the heck are you doing this? Well, first off, what happens? Well, these x squared terms I can, like, cancel, right? Like, it's the factor that's in the numerator and denominator that are the same. So x squared over x squared is equal to 1, so I can get rid of it. So then I'm like, okay, so what do I have left? I have the limit as x approaches infinity of 1 plus 1 over x all over 2 plus 1 over x squared. Now what we do is we use the properties of limits to evaluate this. What's the limit as x approaches infinity of 1? Well, it's going to be 1. Plus, what's the limit as x approaches infinity of 1 over x? Well, we just did that here. It's equal to 0. So this is going to be plus 0. And then over, what's the limit as x approaches infinity of 2? Well, guess what? It's just 2. And then the limit as x approaches infinity of 1 over x squared, well, that's the same as this one. It's just getting to 0 much faster. So this is also plus 0. And then we get our answer. I know you're probably like, yo, that was easy. All right. So I common factor out the highest term, or sorry, apologize for the language. I factor out the term with the highest degree, the squared term, cancel it out, and then I use the idea that the limit as x approaches infinity of 1 over x, this one right here, is equal to 0 to help me figure it out. All right, here is another one. If I look, okay, so I have the limit as x approaches infinity of x cubed plus 6x squared over 2x squared plus 5x plus 6. So if I look, well, okay, so the top, I can take out, okay, I have an x cubed. So I'm going to be left with 1 plus 6 over x. And then over this one, I can take out an x squared. So I'm going to be left with 2 plus 5 over x plus 6 over x squared. Okay, now here, a little warning, okay, we have a problem. Because see, like, how does this cancel? Well, check it out. Like here, like this x squared will go away, but I'm going to be left with an x to the power of 1. So here, if I write this out, I have this, and then I have x, then I have 1 plus 6 over x, all over 2 plus 5 over x plus 6 over x squared. Now again, if I use the properties of limits, because in the last example, now I could just say, well, okay, what's the limit as x approaches infinity of 1? What's going to be 1? Plus the limit as x approaches infinity of 6 over x, well, that is 0. Over this limit as x approaches infinity of 2, well, that's just going to be 2. Plus the limit as x approaches infinity of 5 over x, well, that's going to be 0. And then plus 6 over x squared, that limit as x approaches infinity is also going to be 0. However, we got this x right here. Okay? So what's the limit as x approaches infinity of x? Well, unfortunately, that is infinity. So this stuff doesn't matter. Okay? What's infinity times 1? Infinity. Infinity divided by 2 is still infinity. So this one, the limit as x approaches infinity of this whole thing is positive infinity. Okay? So hopefully that's cool. All right, that's a short lesson. No big deal. So yeah, hopefully you're all good with that, and we'll talk soon.